Jim saves for a car. He deposits $500 every 6 months into some form of investment that pays 4% semi-annually for 6 years. Any idea how you guys would solve this without knowing what I'm going to teach you in like 20 minutes, 15 minutes? Because you could do it. You do have the skills to do this. How would you do it? Shelley, how would you do it? Very good, yeah. I know. To solve this problem, and I watched you walk in the office too, didn't I? To solve this problem without some fancy-dancy software, an app, we need to calculate every payment. Okay, because you know how to do that. You know how to take some lump sum and find out how much it is going to be in the future. Given the rate, given the amount of time, given the frequency of compounding. Okay, you got a formula for that. Here's the problem. You got lots of payments here, don't you? You have lots of lump sums. So, like, we're not going to do this. I just want you to understand how tedious this would be. Okay, so this is every 6 months. So if I start it now, that means in 6 months, he plunks down $500, right? So at the end of 6 months, okay, we have 5.5 years to go, right? Because this was for 6 years. So in 6 months, that means 6 months has gone by, you got 5.5 years. So you know how to do this. 5.5 years semi-annually is twice a year. So 5.5 times 2, n is 11. Right? In our compounding formula. And I, this is 4%, but I need a semi-annual rate. So 4% divided by 2, that's 2%, or 0.02. Okay, that's what goes in our formula. This is just for the first payment. Okay, so the amount would be P1 plus I n. Okay. Now, how many more times would we have to do this? In another 6 months, I got another payment, right? So I would have 500. It's the same rate, compounded semi-annually, but n now wouldn't be 11. It would be 5 years to go. 5 times 2 is, okay? Any idea what the next one would be? Yeah, you see a bit of a pattern here? 1.029. All these I would have to add up, right? One at a time. I'm not even going to write them all because that's kind of tedious. right down to the last payment. How much time would be left at the last payment? A year to go, 6 months to go, 0 years to go. That's right at the end of 6 years. Like he's depositing at the end of every 6 months, right? So at the end of 6 years, that's his last final 12th payment. Okay? And as you can see, we started at 11, so I'll get 11. I'm going to have to add this. That'll be my 12th payment. Okay? So I need to add all of these up. I mean, who would want to do this? Okay? Thankfully, I'll show you a nicer way to do it. But it's nice to understand why you can't do this, okay? Unless you use some technology. So, we need software. Now, luckily, this isn't back in 1970, even 1980. Like, they didn't have these things when I was in high school, okay? But we didn't get questions like this. But, you know, people working at NASA and stuff like that before computers, they had chalkboards 20 feet high, and they had ladders. And these guys worked at the top, and a couple guys worked in the middle, and guys worked at the bottom, and then they stood back about 100 feet and looked at their equations and their problems, and then they went back again and worked, and that's how they did things, right? They still sent rockets into space, right? Like they were still smart, even without the software. But now, thankfully, you guys can do this kind of stuff in grade 12. Okay. This is called a TVM app, and you have one in your Texas Instruments 83. TVM stands for time value of money. Time value of money. You remember that compounding graphic I showed you where you invested a little bit of amount over 100 years and it turned into 2.2 million? Value, right? Time value, you get lots of money. So in your 83 or 84, here's what you do. You see your apps button? You press it. Right there. Mine's blue. Now, if you got an 84 like Brittany here, you got a lot more options under applications. You want the finance one. So you just press the first one, enter. Okay. And then we want TVM solver. So you just press enter again. Okay, so app, enter, enter. And we're going to have a big kind of a screen that looks like that. Okay, I'm going to write out what all the stuff is. N. We got I. We got PV. Any idea what that stands for? Present value. PMT. Good guess though. FV. P/Y, C/Y, and then on the bottom, payment, it says end or begin. And you see how the end is highlighted there? Okay, so that's what your screen looks like. So this thing's pretty smart. If you put in the right numbers, it'll solve for whatever the heck you want. It'll solve for N, it'll solve for I, the present value, the payment, the future value, compounding periods per year, payments per year, anything. Okay? But like every computer, garbage in, garbage out. Make a mistake, and it's not going to give you the right answer. Okay? So it sounds really easy, but can be tricky. So payment end, I'm just going to circle this one. That's the default. That means, okay, the payment is at the end of the period. You know the example I just did? Every 6 months, he made a payment at the end of 6 months. I could have made a payment at the beginning of every 6 months. Okay? It still would have been the same amount of payments. I would have had a bit more interest though, because now my money's in there sooner. Okay, what is N? It's the number of payments. I, yeah, it's interest rate. But unlike your formula, you don't change it from the annual rate. Okay? Don't make it half if it's semi-compounding. Don't make it a quarter if it's quarterly. You just keep it as per year. I'll write that again in a bit. This is the present value. You know how to solve for that in the formula, but not with payments. Speaking of which, that's payment, PMT. FV, guess what that is? You bet. P/Y, how many payments per year? If it's semi-annual, that's a 2. If it's quarterly, that's a 4. Hopefully, compounding periods per year will be consistent with that, okay? Because you don't want to have payments monthly and compounding semi-annually. It's possible, but usually our questions are consistent, okay? If it's semi-annual payments, that's when it's going to compound too, okay? So usually these are the same. Those are compound numbers per year, okay? How many times it compounds per year. Okay, so for the problem we just did, and we didn't even figure out the answer, did we? Because I don't want to sit there for 20 minutes trying to add all those up. What do we got? What was N? Number of payments total. 500 every 6 months for 6 years. Twice a year times 6 years is how many? 12, right? I. That's the annual rate. I don't care if it compounds every 6 months. I is 4. Okay? So here we're going to make a little note. That's the annual rate. Present value. What did we start with? Careful. He deposited 500 at the end of 6 months. He started with nothing. Yeah, present value when this thing started was 0. Okay? The payment was 500 every 6 months at the end of 6 months. Okay, what else do I need to know? Well, future value, that's what I'm trying to find out, right? So payments per year, every 6 months, twice a year. Compounding per year, it says semi-annually, and you'll notice when you put that in your calculator, it'll default to that too. Okay, so let's plug this stuff in. How do we get this thing to go? N is 12. I is 4. Present value, nothing. Payment, 500. Future value, that's what I'm trying to find out. Payments per year, 2. How many times does it compound? You notice I didn't even hit 2? I went down to it and it said, okay, if payments are 2 a year, then compounding's probably 2 a year. I could change it now, but it normally defaults to that. And it defaults to the end of the period. I don't know if we're going to have any questions where he deposits at the beginning, but if it is, then I would change that to beginning. Okay? Now, how do I solve for FV? Let's write it down first. Solve. So FV, put the cursor over what you're trying to solve for, FV. Then there's an alpha button, press that. And then second function, if you see under the enter button, in green, at least on mine, it's different if you got an 84, it says solve. Okay, so you press alpha. There it says a little A cursor, solve. There it is. Okay, so someone took a lot of time to program this thing. That's how much I have. Negative. Does it look like it kind of makes sense? How much did he put in? We'll do that in a sec, right? Let's figure out the interest he made. But 500 a year is 1,000 a year for 6 years. He put in 6 grand. Does that look reasonable? Sure. 700 bucks in interest, 706.04. Seems reasonable, right? You always got to look at your numbers and say, does it kind of make sense? Okay, so minus 6.7, I'll explain that minus in a sec here. And this is money, so we want to round it 0.04 cents, unless you're a bank. Okay, so that's how much you got, 6,706 back. So F value is, well, I'm not going to say always. It's negative because this thing is actually, it works on cash flow. Okay, because the payments are leaving you, they're going out, then this future value looks like you're in the hole minus 6,700 bucks. Okay, if you put the payments as negative, then the future value would be positive. So it's like money coming into me. Okay, don't worry about it. Just if you're solving for this, know that this answer is going to be negative. And if you're going backwards, if they give you a future value and you want to solve for present value or payment, you got to put a minus in here, or it'll say invalid. Okay? So just future value is negative. Okay? Comes out negative, or you got to put it in as negative, and everything will be hunky-dory. Okay? So that's it. I don't want to give you another one. That should be enough. How do you get out of this app? Try clear. Does it work? Oh, darn it. You see this quit button here under mode? That's how you do that. Second function, quit. There's other ways. You can push a bunch of other buttons and then a bunch of other buttons and then try to come back. That's the easiest way. Okay? Or other buttons and this and that. Yeah, okay? All right? So, 55, number 1 to 4. And then I'm going to write here, go back and let's try again the last couple from last day. Okay, but do this first.